So when we did average rate of change, we kind of started looking at secant lines, but now we're going to take a deeper dive into them and then kind of extend them to tangent. Now you've probably, well, I know you've heard the word secant and tangent when it comes to trig, right? Secant, cosecant, tangent, blah, 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 blah. But you also heard about them when you were younger in geometry and you were doing circles. And a secant line touched a circle in 2 points, and a tangent line intersected a circle only once. And so that's what we're dealing with here, are those types of lines, but now we're applying them to graphs. So I'm going to draw two parabolas here. Okay, and I probably should actually put my parabolas on here. I'm going to do my best to make them look somewhat similar, but if yours don't look the same, I mean, within reason, like mine got a little skinny over here, it's okay. We're not here to judge. So in the first one, I'm going to pick 2 points. I'm going to pick a point here. And before I forget, I'm going to pick a very close to matching point on the other graph. So I have kind of 2 points I can compare. Now, I'm going to draw in a line in my parabola. And that line crosses the parabola in 2 spots. And it doesn't really matter where I put that line, because no matter at least the examples I'm looking at right now, all of these lines are hitting the parabola twice. So they are secant lines, which is great. Secant lines are wonderful. They can tell us some good stuff about the graph. They're very useful for average rate of change, right? This first one I drew has a negative average rate of change because the slope of that secant line is negative. But I can do this thing. Where I take my secant line and I move it closer and closer. So this is my secant line, and if I keep tipping it, eventually I get to here. Still secant, hits twice. I could tip it more, I get to here. But if I get it just perfect, I can end up with a line that intersects the graph at that point just one time. And when it intersects the graph at a specific point, right, depending on the shape of your graph, it might come back around and hit it again later, but in that area, at that point, it only touches that spot once. Now, just like in our circle, that is called a tangent line. And we're going to do some digging into tangent lines and what their slopes tell us. But basically, a tangent line, because it hits only at one spot, the slope of our tangent line is called the instantaneous rate of change. It provides a snapshot of the graph at that exact moment. So we are going to be start looking more and more at tangent lines on graphs, and they're not scary or anything, but they are going to ask you to be a little bit more specific and a little bit accurate with your drawing. Even my drawing kind of sucks, but I did my best, and hopefully you can kind of get a feel for what does it mean to be a tangent line. So There's Desmos that goes with this, and that'll help you kind of wrap your brain around it a little more. So you got this.